All right, so finally what we're going to look at now is how to actually solve logarithmic equations. So we're going to start with a few more straightforward ones and then make our way to some things that are going to require some log rules. So the first equation here, we've got two base 5 logarithms. You will need consistent bases, otherwise you won't be able to get very far with these. So we do have 2 base 5 logarithms. The fix on this is to just cancel them out with a base 5 exponential. And then what we'll end up with is just that the inputs are equal. 3x plus 2 equals x plus 5. And we should be able to solve that. If I bring the x's over, I get 2x equals 3. And so x equals, was that 3 over 2? Yeah, so there's not too much to that equation. The second one looks pretty similar. We're going to do the same thing. I'm going to take 21 to the power of both sides. And I'll get 2x plus 7 is x plus 2. Bring my x to the left. I get x is negative 5. So what I'm going to tell you here is that that's actually not true. I'm not going to make that quite so obvious. I'm just going to cancel it out with that red. There's actually no solution for this one. So it's not completely random. It's because the x that you get actually has to be in the domain of the equation, both sides of the equation. So here, x equals negative 5 is not in the domain of either of those logarithms. So it's not in the domain of either any log base 21 of 2x plus 7, right? Because if we plug it in, we end up getting a negative, or x plus 2. And so it's not just the fact that it's negative, it's that if I plug that in, I end up getting log 21 of negative 3, which does not exist. Or I get log 21, well, that's also negative 3, and they are both the same, but neither of them exist. You can't have a solution that's not in the domain, so that's going to be a big problem. So what we're gonna do is we're gonna have to be mindful of that. And a lot of times when we solve for these equations, we're gonna generate some solutions that don't quite work. And we'll see that as we work our way through some of these. The next one, log base 2 of x equals 6. So in this case, we don't have a log on both sides, but we can do the same trick. Just take 2 to the left and 2 to the right. You do have to remember that this is 2 to the power of 6. So it's not 2 times 6, and it's not 6 to the power of 2. It's 2 to the power of 6. So on the left, we're going to get our cancellation, and that just gives us our x. And the right, 2 to the power of 6 is 32. So that one's done. I'm just going to get rid of that on the bottom, as it's going to take up some of my space. So on this next one, I'm going to do a really common mistake, is that what I might see is that someone might give me a next line of this, x plus 8 equals x plus maybe 3 to the 2. So this is not going to work, because what somebody would have done to get this result is they would have done 3 to the left side equals 3 to this term plus 3 to that term. That's not how equation solving works. It's always entire left side, entire right side. So I'm going to have to fix that. So what I'm going to have to do is 3 to the left side to cancel, and then it's going to be 3 to the entire right side in one go. And so what I'm going to get here is x plus 8, and it doesn't look good, but it's fixable. So it's going to be 3 to the log base 3 of x plus 2. So this is fixable because what we can do is actually separate that exponent. So we can separate that and write it as a product of base 3's. So we can write 3 to the power of log base 3x times 3 squared. And then now I get that cancellation again. And so what I actually have here is x plus 8 equals, that'll be x times 9. So 9x equals x plus 8. We should be able to get x equals 8x. And so our answer is going to be x equals 1. And double check, make sure it makes sense. You can actually check the answer there. Log base 3 of 9 is 2. On the right, we have log base 3 of 1 is 0 plus 2. So left side equals right side. So it does work. So for D, what I'm going to do is actually just redo on the left here an alternate solution for it. And it's going to be more in line with a strategy that you can usually use. So what we can do is combine the logs. So what we could have done is brought the other log over to the left, like this, and kept the 2 on the right, and then combined this using our log rule. So if you remember the rule, log A minus log B is division inside of the log. So we could have actually written this as log base 3, I'm missing that. That's not an eraser. So log base 3 of x plus 8 over x equals 2. And then done our base 3 on both sides, and that will cleanly cancel it right now. So we get x plus 8 over x is 9. And it is a rational equation, so maybe you don't like that, but it's not too difficult to solve. We just bring the x up, x plus 8 is 9x, and you can see we are right here in the equation. So we should get the exact same result. So I do recommend that strategy to, for the most part, bring the logs together. Generally, I'll give you a slightly different strategy, but it's going to be a little bit more in line with the second way we solve this problem. All right, so we've got some slightly more complicated looking logarithmic equations here. And so the strategy that I wrote at the top there is we're going to solve most of these equations by getting them into one of these two forms written above. So we either want everything in one side as a log and then the other side's just a number, or both sides are both entirely written in a log, and just like a single log. So if we look at the first one, what we've got on the left is 2 logs. So what we're going to do is combine them. And that's just using our log rules. So that addition on the outside is going to become multiplication on the inside. And I'll just simplify that. So we should get multiply that out, x squared plus 4x minus 12. And that should be equals 2. So now that I've got it in that form, what I'm going to do is use this, whatever that base is that goes with the logarithm to cancel. So I'm going to do base 3 logarithm on both sides. And so now what I should have is the logs cancel. I have x squared plus 4x minus 12 equals 9. I can pull the 9 over. I can see that this is now a parabolic equation, a quadratic. So hopefully it factors. It does look like it will. And once I get that 0 on the right-hand side, I'm good to factor. It'll give me x plus 7, x minus 3. And then my answers will be -7 and 3. But I am going to check both answers. If I plug 3 into both equations, I would get, or into both logarithms, what I get is an inside of 1 and an inside of 9. So that's good. Those are perfectly acceptable insides for logarithms. But if I plug the -7 in, the insides are going to be -9 and -1. And so basically what happens is that -7, it solves this equation here, but the issue is that when I combine those two negatives in the logarithms, the two negatives made a positive, so it contributed these answers that couldn't have happened. So that -7 is going to get rejected. My only answer for this will be x equals 3. So that's that one. The second one, we've got something pretty similar here. I've got the 2 logs on the left. My right side's good. It's in a single log. So again, just combine. Same thing. So I'll get log base 2 of x times x plus 2 equals log base 2 of 4x. I'm going to do 2 for 1 here. I'm going to use the base 2 to cancel my logs because I've now got it in that second notation. And then in the next line, I'm also going to simplify the left-hand side there to get x squared plus 2x equals 4x. And so I end up with x squared minus 2x equals 0, which we can factor. I can pull out the common x. Not an extra one there. So yeah, x minus 2 equals 0. And so my solutions will be x equals 0 and x equals 2. Same reason, x equals 0 does not work. That creates a whole weird behavior in your logarithm. So we're going to get rid of that one. And my answer would just be the 2. So yeah, that should work. And one last one. It actually kind of looks a little bit like the one that I did on the other page there. So what I have is a log plus something equals another log on the right. The easiest notation for me to do here is going to be the first one because of that number. And that's my number 2. So unless I want to have to deal with all the exponential or the logarithm rules, the easiest thing to do is probably going to be to isolate the number and keep that on its own, which means I'm going to push the 1 logarithm over to the right. And then again, use my log rule to combine what's on the right-hand side. And so what I'm going to get is 2 equals log base 9, and so that's going to be division. And I will now use a base 9 exponential to cancel the logarithm on the right. And so what we should get is 81 equals m minus 4 over m. And now solve the rational equation by bringing the m up to the other side. And it looks like we're going to get some kind of ugly fraction, but it's not the end of the world. 80m equals -4. So m is -4 over 80, which should be -1 over 16, but we are going to reject that answer because of both domains. That's not going to work for us. So there's no solution there, none at all. Did just realize that 80 over 4 isn't 16. 80 over 4 is 20. It does not affect the negativity of our answer, though. So it's still a reject. We still have no solution. So yeah, you might get a couple solutions. You might get no solutions for these equations. They're kind of wacky that way.